Welcome to a new test and teardown video. This time it is a Fernschreib Sendermesser. Well, I think it is just an oscilloscope, to be honest. Maybe that is what it means. And the idea is we have this front cover protection for the cable and everything. Pretty nice. Cable is sticking out here in the front. That is a little bit weird, wouldn't you say? And of course it is just an oscilloscope, but I think it is specially made for this RTTY pulse tone beep beep detection stuff. And we got some bow rate adjustment. Remember, 175 or 50. Oh, that is some slow bits per second, huh? And then you can adjust something like that. Some different width of modulation. That was probably the on-off switch. We got some code. I don't know exactly what that one is doing. I know nothing about this one, to be honest. But I think we should open and inspect this thing. I really hope we can find at least a brand name. Or, I mean, there must be some... Aha! There is. But it's still this... here is a type number, TMSE 125A. I'll try and see if I can clean this up and maybe we can make... this looks a lot like Siemens or the Schwarz or something like that. The numbers like that, so it's definitely one of those big German brands. And then there is a really weird special connector. I got no idea how to interface to that one. That is a fuse and a voltage selector. Yeah, let's try and open and inspect this thing. I think I got good news. I'm inside the unit and I cleaned it a lot better. Look what we got here. This is the Siemens logo. So now we got the full name and number for this unit, and I can of course update my descriptions. We even got the full type number and order number or whatever it is right there, so that is fine. Here's a little springy contact for the outer chassis. Everything is of course full of Siemens part numbers. Also on the tubes. This one is a mixed technology unit. So we got 3 tubes. That will be for the deflection, obviously. And that is a high voltage regulator or something like that. Something to do with high voltage, because we can also see high voltage diodes, and all that high voltage stuff is extra protected behind a little plastic shield. I should of course open that so we can better see what's going on. That will be the top of the tube, the anode connection. And this is not an ordinary oscilloscope. We already figured that out, but look at that. In here we see a lot of things that is going on. 16 different plug-in modules, and they look very much the same except for the first one and 16. We got all the capacitors for the high voltage. We can access a selenium rectifier right there. And what else have we got? Voltage selector is there, and a little extra filter choke. And a little circuit board here at the bottom. Like I said, mixed technology, so it's full of transistors and just those 3 tubes. And the quality of the components is definitely tip top. Look at that. And check out the sound. There's a very, very different feel to this switch compared to the normal switches of this time. This is a switch you rotate on off, obviously, and that is the meter for some indications of whatever. I think we should try and open here and have a little look. Oh, this is really smart. So they got some grooves in here that holds all the 16 boards in one little go. And look at that, you click them in and then slide. It was easier to slide it up, but that is the idea with the sliding in out kind of thing. So let's try and look at those circuit boards. So we got two little transistors, resistors or diodes and stuff like that. And I think this is a little flip-flop timer with some capacitors here for the timing. If I take the next one, it's probably some different. I don't know. I'll have to try and look more careful if they change some of the values or something like that. I don't want to swap these around because I really want to see if I can get this thing up and running. If there's any life, we will be able to see what is going on. And the first two modules here, they look a little bit different. Another little transistor and some, two transistors and some other thingies down there. And that one is also different, but in a okay condition. Could be cool if I could find a schematic or something like that. So this will be the left side of the unit. It looks quite boring from this side, but we got some adjustments, brightness, focus and all that kind of stuff, probably height and some pulse things. So I bet there is some sort of a demodulator counter or something, because this looks like something like that. So I can lift these units. Let's see if I don't know if I can do that, but that will be all the trimmers for that. I need to take this away and inspect the quality. So this is the back side of the plug-in modules, full of all sorts of capacitors and stuff like that. Some more transistors and some more funky filters and whatnot. It's like really, really as far away from a normal oscilloscope as you can imagine. That is some funny here. And just to show the compare, I got another one of them. So this is what happens sometimes. I get more than one unit, but this one looks completely different. Behind the circuit board here, look at that. Full of extra transistors. And that is the rear of that board. I mean, this is a completely different revision of everything. So maybe this is doing more or less the same, but just in another way. So this looks a lot older. And something is going on with this potentiometer here. It's really nice and big and shielded and whatnot. So I removed the plastic protection here, and now we can enjoy the fantastic high voltage section. What we see here is of course the high voltage rectifier. So inside those we will have, I don't know, like 50 or 100 tiny little selenium discs, and this way it becomes a high voltage rectifier handling 2000 volts, 2.5 milliamps. I think this is the specifications. So it's running plus minus 2000 volts. So the positive 2000 goes of course to the anode, and the negative 2000 goes to the cathode system down there. This tube right here, the E84L, that is a part of the high voltage section, and what this is doing is it's actually creating this oscillator that drives the transformer and all that. The transformer for the high voltage is inside this metal can we see in here, so it's fully potted and isolated, really nice and fine, but we can't really see it that much. And we can see the top output there with the blue wire. I don't know, I'm not gonna go deeper than that. And there we got some more windings creating this oscillator, and they go of course to this tube. So I think it's fun. This system, or this scope analyzer here, consists of tubes for the high voltage stuff, and of course the two dual triodes here. They are responsible for the deflection system, and they handle high voltages. The rest is low voltage transistor stuff, germanium transistors, early age transistors. And it's really funny to see how they mixed the technologies, because germanium transistors couldn't handle high voltages, and you can imagine all those hundreds of transistors doing all the different counters and filters and whatnot for this RTGY decoder, viewer, timing pulse analyzer thingy. You couldn't just do that with tubes. It would just take too much space. So that is really interesting. I want to try and power this up now, because I didn't really find anything preventing me from doing this. But there's one more cool thing I want to mention, and that is this meter we see here at the front. Have you seen this before? I have. I made a video 3 years ago, also a Siemens. It's called the FSE, Fernschreib analyzer, or something like that. Teleprinter test equipment in English. And I will of course put a link to that old video in my description, so please have a look. That one is also with a scope, and it could analyze the different pulses and whatnot. And actually, I think it worked. So that would be a cool video to revisit maybe. So I am now ready to do the first power up, and I think I will use my Vario and slowly see what happens. Maybe there's a shorted rectifier or a shorted capacitor or some nasty stuff. This is turned on, and we are at 60 volts input. It's using 4 watts, so I mean fuse is okay, transformer okay, but I'm just slowly cranking up. I don't know what I'm doing here. I don't know anything. Just going 100 volts. I think we need to go much higher before we will see anything happen. That was the power on lamp. We are at 150, and I am fast to turn it off if something bad happens. So that will be 200. I should expect we are at 220 now. It's using 36 watts. This is, I see light. Look at that. Oh, we have all the little pulses and all the nice things going on here. Look at that. That is the little code display. So it's analyzing pulses and all the cool things. I'm super happy this works. This is normal, and this is with the pulse indications. How nice. This is the different ball rates, and this of course scanning faster and slower, and I can see it blinks and interferes with my frame rate. So this is 100 ball. That is also working, so timing is working, and this one is variable. What is this doing? Oh, in this mode here we see some lamps in the high voltage section turning on, which did not happen here. That is some, I don't understand what exactly is going on here. So this is some code. I think this is in scope mode and this is in analyzer mode or something like that. Why is it doing that with the high voltage? Let's try and input some frequencies, some pulses, and see if there's any indication. That could be cool. It's a little bit annoying. I really tried everything with the input signals, and this is really a cool lamp switch. I tried everything here, and I can't make it respond to any kind of inputs. So, I mean, there's no way. See, this is a super zoom version, and I don't have this information about how to use it, honestly. It's probably this big multi-connector on the back. Maybe that is where we find the input or something like that. I mean... So I was able to find a schematic at Radiomuseum. It was quite easy. I just searched for this TMSE 125. And then, yeah, okay, the schematic is in 3 parts, so I need to zoom around and all that kind of stuff. But I can see the way that it is supposed to be working. And this input connector I have at the front, that is exactly where I need to put in the pulses, and it's not responding to any of that. So I bet some of the input circuits they've been blown up. And in the other unit I got, or tried to measure some of the transistors, they're just either shorted or open or something like that. It's not good for all those old germanium transistors. So that is, of course, why I'm not getting any inputs in this one as well. Probably everything here is half dead anyway. But I think it still was a lot of fun to look inside this unit. I will maybe zoom a little bit around here on the schematic so we can see what is going on with all the different inputs and the different counters, all the different, each of the little plug-in modules. It looks like there are JK flip-flops actually, each of one of these doing some timing and some flip-flopping pulse detection. So I bet when you come with the right pulses for your transmitter, teleprinter thing, you will be able to detect if it's good or bad pulses and what not. And I was right about the high voltage power supply, about this tube doing this oscillator and the transformer inside this little can, and it's running plus minus 1500 volts. So that is a little bit below the maximum for the diodes, obviously. So I'm not going to do any more with this unit today because I don't think it's really worth spending another 100 million hours on, because the input is just dead and it's going to take me too long to work around with this anyway. So thank you very much for watching. I hope to see you soon. Bye bye.